Hello students, in this video lecture we will learn to determine the dimensional formula and dimensional equation of some physical quantities. Okay, so please do concentrate on the procedure and do not worry too much about the formulas. Okay, these formulas you will learn as you learn the topics or the chapters in this 11th class physics. Okay, so only concentrate on the procedure, how to determine the dimensional formula and dimensional equation of a physical quantity. It is very important because if you don't know how to determine the dimensional equation of a particular physical quantity, then you will not be able to apply the dimensional analysis, or you will not be able to learn the dimensional analysis. Okay, so it is very important. So let's see some questions. Okay, so there is a first question. So here we need to determine the dimensional equation for G in universal gravitational constant, then surface tension, then thermal conductivity, and the viscosity. Okay, so we have formulas. These formulas are given in a question. So first formula is for gravitational force. So gravitational force is F is equal to G m1 m2 upon r square. Okay, so G is a gravitational constant, F is a force, m1 and m2 are the masses, and r is a distance between these two masses. Okay, now to determine a dimensional formula for G, you first arrange this equation in this form. So G is equal to F into R square divided by M1 M2. Now write both sides. SI unit of G is equal to SI unit of this quantity. Now SI unit of force is Newton and SI unit of distance is meter, and for mass, kilogram into kilogram, you will get kilogram square. Okay, so SI unit of G is Newton into meter square divided by kilogram square. Okay, now this is my suggestion that you learn or you remember that the dimensional formula for force. Okay, because the force will come in number of formulas of physical quantity. तो फोर्स आप ध्यान रखें कि फोर्स की जो डायमेंशनल इक्वेशन हो जाती है m1 l1 t minus 2. Okay, so you put directly here. So Newton is a SI unit of force, so put a dimensional formula for force m1 l1 t minus 2. Okay, now meter is a SI unit of length, so put length के लिए l रखें यहाँ पर l raised to power 2, and for mass, for kilogram you put mass. Okay, because kilogram is a SI unit of mass, so this is m raised to power 2. सॉल्व करेंगे इसको, सॉल्व these values, you will get m raised to power minus 1, l raised to power 3 and t raised to power minus 2. So this is a dimensional formula for G. Now you equate it with a physical quantity, you will get dimensional equation. So this is a dimensional equation for G. Okay, so please do remember the procedure. Okay, so and follow this procedure, you can be able to determine the dimensional formula of any physical quantity. Now the second physical quantity is surface tension. So SI unit of surface tension is Newton upon meter. Okay, what is surface tension? It is a force per unit length. Okay, so SI unit of S is equal to SI unit of F by L. F for F use Newton and for L use meter. So Newton upon meter. Now to determine a dimensional formula, write dimensional formula for force m1 l1 t minus 2, and this l1 for this meter. Meter is a SI unit of length, so for length we use L, so L raised to power 1. You solve it. By solving you will get m1 l0 then t minus 2. Okay, so this is a dimensional formula for surface tension. Now you equate the quantity, physical quantity with this, then you will get a dimensional equation. Okay, now next is thermal conductivity. So formula is given in a question, so you arrange this equation in this form. So K is equal to QD divided by A delta theta then small t. Here Q is a heat, D is a distance, A is a area, delta theta is a change in temperature, and small t is a time. So again arrange this. SI unit of K is equal to SI unit of this quantity. So SI unit of heat is joule, distance की SI unit मीटर, एरिया की हो जाएगी मीटर स्क्वायर, चेंज इन टेम्परेचर की केल्विन, और टाइम की सेकेंड. ओके, सो बाय दिस यू कैन गेट द SI unit of thermal conductivity. Now joule we can write Newton into meter, जूल को आप क्या लिख सकते हो, न्यूटन इंटू मीटर. नाउ कैंसिल आउट मीटर टू मीटर, then you will get Newton upon Kelvin into second. Okay, now again we know that the dimensional formula for Newton is m1 l1 t minus 2. For Kelvin you will get, when you bring it above, you will get k raised to power minus 1. Then for second is SI unit of time, so bring it above, you will get t raised to power minus 1. So when you solve it, you will get dimensional formula m raised to power 1, l raised to power 1, t raised to power minus 3 and k raised to power minus 1. Okay, so this is a dimensional formula. When you equate it with the physical quantity k, it is a dimensional equation. Okay, now let's move to a next. So next is coefficient of viscosity. Now raise this equation also. So you'll get eta is equal to F force divided by A area, then delta V is change in velocity and delta X is change in distance. Okay, so SI unit of eta is equal to SI unit of this quantity. So SI unit of force is Newton, SI unit of area is meter square, SI unit of this change in velocity is meter upon second. Okay, now SI unit of this distance is meter. So cancel out meter to meter, you will get Newton into second upon meter square. So this is a SI unit of coefficient of viscosity, Newton into second upon meter square. Okay, now again for Newton, write a dimensional formula for force m1 l1 t minus 2. For second is a SI unit of time, so write t raised to power 1. And for meter, meter is a SI unit of length, so this is l raised to power 2. When you bring it above, you will get l raised to power minus 2. So solve the powers, you will get m1 l minus 1 t minus 1. Okay, so this is a dimensional formula. When you equate it with the physical quantity, you will get dimensional equation. So this is a dimensional equation of coefficient of viscosity.